right, for lesson 19, we are going to be working on percents. This might be something you're already a little familiar with, but we want to specifically use proportional reasoning to work through percent problems. So noting this down, a percent is a specific kind of constant that can be written as a fraction with a denominator of 100. You can also write percents as a decimal, but I'm going to focus on only writing them as fractions because sometimes you'll get fractional percents. So an example here, 25% could be written as 25 over 100. I have a couple questions that I want you to just answer. What that percent. All right, so for the first couple problems, we're going to be using the equation y equals kx. This is something you're familiar about from proportional equations. In this case, k, our constant, is going to be the percent as a fraction. And then for y and x, y is always going to be the part, and x would be the whole. Or x would be the original, y is the new value. It kind of is flexible depending on the problem. So for number one, it says cats sleep about 65% of the day, or 65 hours for every 100 hours. About how many hours do cats sleep in a 24-hour period? So this 24-hour period is telling us the whole. That's the entire amount. 65% is obviously the percent, and what we need to find out is the part. So you're going to write 65% is 65 over 100. X is 24. So plugging everything into the y equals kx formula, we get y equals 65 over 100 times 24. This is a relatively simple one because we're just multiplying. There's no kind of equation solving going on. So you get y equals 1,560 over 100, or 15.6. And of course, we want to make sure we always answer with a full sentence. Cats sleep 15 and 6/10 of an hour in a 24-hour period. For number two, then, the city employee estimates that 5 out of every 7 cardboard boxes gets recycled. About what percent of cardboard boxes get recycled? So I want you to tell me what y is in this instant, what k is in this instant, and what x is in this instant. Keeping in mind, one of those is something we don't know. So we should have gotten our part y is 5 and our whole x is 7. 5 out of every 7. And then our k is going to be the percent, which we don't know. So you're going to write that as p over 100. So you see the equation y equals kx gets rewritten as y equals p over 100x. And then we can plug in the 5 and the 7 here. And to solve, you rewrite it with your kind of fractions rearranged. So you get 5 equals 7/100 times p. You multiply by the reciprocal to solve, which of course cancels out. 100 over 7, hundreds cancel, sevens cancel. 100 over 7 times 5 gives you 500 over 7, which is then 71.42857. I'm going to round to the tenths place here. So about 71.4% of boxes are recycled. All right, number 3, Mrs. Banks purchases a new computer monitor. Its diagonal length is 133 and 1/3% of her old monitor's diagonal length. Her new monitor has a diagonal length of 24 inches. What is the diagonal length of her old monitor? So this is where I'm saying new and old might be what you're looking at. So again, identifying your y, your k, and your x for me. Y is 24. That's going to be the new length because the new one is what is being referenced by this percent. Percent is 133 1/3. You write that as a fraction over 100. I know this is a messy looking fraction. It'll be not too bad once we solve. And then x, of course, we don't know what it is. Here's our equation we're going to plug everything into. So we end up with 24 equals 133 over 100 times x. We multiply by our reciprocal again. So we multiply 133 over 100 by 100 over 133 and 1/3. And then, of course, doing that on the other side. And then you end up with 18. If you plug it into your calculator, you do 100 over 133 and 1/3 times 24, you get 18. So this means the length of her old monitor was 18 inches. So all of this is using the y equals kx formula. You're probably fairly familiar with this. But now we're going to talk about using the equation a over b equals c over d, or setting up a proportion. This is why I thought it was so important for you to get used to writing percents as fractions, because that'll help you make this transition. So we have two different people, Dylan and Sohee, solving this problem. Sarah bikes 40% of a route. Her route is 15 miles long. How many miles does she bike? And I will have this written down below for you, but I'm just going to talk through it while it's on the screen. For Dylan had 40 over 100 equals x over 15. He multiplied by his reciprocal there, or undid the division by multiplying by 15. And then 15 times 40 over 100 is 6. That's how he gets Sarah biked 6 miles. So he did something a little different that looks a lot more complicated, but I promise you there are times that make sense to apply this. So he started with the same equation. She's written it backwards, but that doesn't matter. X over 15 equals 40 over 100. She then multiplied by 100 over 100 on the left and 15 over 15 on the right. Now, even though these look different, these fractions are the same thing, because she's just multiplying by 1. A number over itself is 1. So that leaves her with 100 x over 1500 equals 600 over 1500. And what you'll notice is the denominators are now the same. She has created an equivalent denominator. And because the denominators are the same, she can set the numerators equal to each other and get the new equation, 100x equals 600. She can then divide by 100 or multiply by 1 over 100 to get that x equals 6. Sarah bikes 6 miles. So they did slightly different things, but they got to the same answer. You're gonna pause, you can write down this explanation. My main takeaway here is that even though Sohee's problem looks much more complicated, there are times solving in her method actually is really helpful. Going on to number 5. We have, of 600 students, 90 signed up to volunteer. What percent of students signed up to volunteer? Write and solve a proportion. So I've already given you 90 is our y, 600 is our x, and p is what we don't know. And the proportion can be written as y over x equals p over 100. I want you to choose which option you think is the correct way to write this proportion. So your proportion should look like this: 90 over 600 equals p over 100, y 90, x is 600. I'm going to go through both methods for this one, and then on the next couple problems, I will kind of pick and choose. So for Dylan's method, we do the same thing. We're going to multiply by 100 to undo that division. So now we're multiplying both sides by 100. 100 times 1 over 100 gives us 1, so that leaves us with just p on the right. On the left, we have 100 times 90 over 600 gives us 9,000 over 600, which gives us our p. And then if we divide 9,000 divided by 600 gives us 15. On Sohee's side, we're going to start with the same proportion. 90 over 600 equals p over 100. And then we want to pick whatever the lowest common denominator we could figure out between these two. And luckily, because 600 is a multiple of 100, we can just use 600. So I haven't done anything on my left, but I've multiplied the right by 6 over 6, which, remember, 6/6 is a fraction that just still equals 1, so I'm not actually changing anything. So we multiply by 6 over 6, which gives us 90 over 600 equals 6p over 600. And this is where we're at that point where our denominators are the same. And that means we can set 90 equal to 6p. We're just going to divide by 6 then, and we are left with 15 equals p, which, because we were trying to find the percent, that tells us that 15% of students signed up to volunteer. So this is one of those cases where Dylan's method looks better because it's so much faster. Number 6 is the example I'm going to use for when Sohee's method makes a lot more sense. Give me for number 6, I haven't highlighted these, but I think you should be able to figure it out by now. For number 6, tell me what the y, the x, and the percent is that you are given, one of which we don't know. So what you would have gotten for Nora runs 2 1/10 miles. She's 35% finished with her route. Y is going to be 2 1/10 because that's how much she has already run. X is going to be what we don't know. That's her entire length of her route. And then the percent, of course, is 35%. That one's the easy one to figure out. And so that leaves us with an equation that looks like this. 2 1/10 divided by X equals 35 over 100. And my note here is that you can also create common numerators with Sohi's method. Having our variable in the denominator of a proportion makes proportions kind of awkward to figure out because you end up with this, like, you have to do a bunch of extra steps to end up with your variable no longer in the denominator. So we're going to use Sohi's methods here, but we're going to find a common numerator. So what we're going to multiply on the left here, we're going to multiply the left by 35 over 35 and the right by 2 1/10 over 2 1/10. Ultimately, it doesn't matter what our numerators end up equaling because we know they're going to equal the same thing. 35 times 2 1/10 is the same as 35 times 2 1/10. But just for the sake of showing it, we end up with our numerators equaling 56 5/10, and then our denominators equaling 35x on the left and 210 on the right, which leaves us then we can rewrite that as an expression, the equation 35x equals 210. And this is a one-step equation, so go ahead, finish solving this one on your own. Now we're at the end of the lesson. We have there are like 5 problems left. I don't want you to solve any of them. You can use whatever method you would like. So you could use the equation y equals kx from the beginning, or y equals p over 100x from the beginning. You can set a proportion and use Dillon's strategy. You can set up a proportion and use Sohi's strategy. Whichever one you want to use is perfectly fine. You are going to pick 3 of the problems from the 7 through 11 to solve on your own. Raise your hand, let us know when you are finished.